Okay, girls, you want to hear a terrible tale? But somewhat exciting, somewhat technical.
Yes, Master. Anything's better than you shooting us on the range.
Yeah, okay, fair enough. Okay, I'm going to talk to you girls about the history of chemical warfare.
Oh, chemical warfare?
Yes, indeed, girls. So, you obviously know in World War One, there were gas attacks, gas shells, gas canisters being used, all that kind of thing. Do you think that was the first time in history that chemical warfare was used?
Oh, I doubt it, Master, or you wouldn't be asking the question.
Very good, Sparehead. No, so even go back to the Bronze Age, and maybe Master Chris Andre could help us here, but Hercules apparently dipped his arrows in the venom of the Hydra monster, and he used that. And going through history, people have used various poisons, on throughout war, dipping weapons in different poisons, different things like that. We won't go into biological warfare. There's obviously a long history of that. Particularly interesting one that we might go into in the future is the Black Death, 1347, 1348, that kind of thing. But
get to the point!
All right, Akunoa. Okay. So, in more recent times, well, not more recent necessarily, the Amazonian tribes, you know what they are?
Oh, they live in the Amazon?
Interesting question, girls, just a digression. Do you know what Amazon means?
I like a body, but don't they like breasts?
Very good. Maison. Mastectomy, to do with breasts. Greek for lacking breasts. So an Amazonian warrior was a woman fighter with no breasts. She would have cut the breasts off. But that is a total digression. I mean, it's not relevant at all. But what they would do, the Amazonian warriors, they would dip their arrows in something called curare. And do you know what that would do?
Oh, paralyze the lungs. Luckily, we don't have any of those.
Yeah, and that's given rise to the drugs we have today, like pancuronium and all those sorts of things, that we actually use to block the neuromuscular junction in the lung during surgery. It blocks all the nicotinic synapses, and so you can't breathe, you don't make secretions. That's the important thing. You're not secreting into the lungs, so you're not filling your lungs up with fluid whilst the doctor operates.
All right, Master, but get to the point.
Yeah, right, fair enough. Okay, but I'm going to get to World War One. We're going to talk about a few things here. In World War One, was chemical gas, was that a really significant weapon?
Yes, Master, it killed many people.
Surprisingly not, actually. Less than 1% of the deaths of World War One were actually caused by gas. But when we actually look at casualties, were they higher?
Very, very much so, Master, I suspect.
Yeah, because most of the gases were not killers. They were agents that would paralyse the troops, that would terrify them, that would make them feel that they were suffocating and make their eyes burn, their noses burn, their lungs even burn. And so they would run and they would flee. But usually they weren't killers. Now, the first example of this, is chlorine. It's the 22nd of April, 1915. This is the first mass example of chemical weapons being used, really, in history. 150 tons of chlorine gas was released from cylinders, much like that one there, all over the lines. Now, the Germans were lucky. Not lucky, I'm sure they predicted it and then they're methodical. The prevailing wind across Europe blows from west to east because it's a westerly wind because of the Atlantic Ocean. But on this day, which way was it blowing?
I guess east to west.
Yeah, it was blowing east to west, blowing the opposite way to normal. And so they released their gas on the Ypres, 22nd of April 1915, against French colonial troops. And what do you think happened?
They ran?
They ran. And who can blame them? I'd have run too. And then, just 2 days later, against the Canadian division, also at the Ypres, again, the Germans, it worked the first time, they tried it again. They released it on the Canadians. And what happened?
I suspect they ran, Master.
There were all these clouds of gas slowly crawling towards them at the pace of a crippled crab. But they were coming forward, and the Canadians didn't know what to do. They'd not seen this before. And suddenly they're enveloped in this cloud of of sort of greeny, yellowy gas that kind of clings in the shell holes, clings low to the ground. It's just on the point of turning into a liquid, actually. You're kind of on the cusp of that with the temperature. And then they realise, what do they realise?
Oh, I should think they're breathing it in, Master. And they're choking and they're gasping and they're gagging.
Yeah, they're breathing in, and the effects of chlorine gas, because that's what they use, I didn't mention already, this was chlorine gas, it was causing pulmonary edema.
Oh, I don't have to worry about that because I don't have lungs or a body, but I suspect that is fluid filling the lung.
That's quite right, yeah. Their lungs were just filling up with fluid. And of course they ran. But on that day, a Victoria Cross was won by one machine gunner who refused to run. He just stood there.
He just stood there, firing off his Maxim gun.
He did. He just didn't give a damn. He just stayed there, blasting off his Maxim gun. And then a few hours later, of course, his mates came back to look for him. And he was there, dead on the ground. And that's what would happen if you stayed too long in the gas. But usually with chlorine, very, very few people were killed. It would give you serious lung trouble if you stayed in it too long. Who was behind all of that mass attack?
This would be Master Fritz Haber, the great chemist.
Yeah, not a very nice man. I've never liked Fritz Haber. He did develop the Haber process, process of making ammonia from methane and atmospheric nitrogen, which was a great process. But, do you know, before, I don't know the exact date, but his wife took her own life when she heard about what he'd done with this terrible, horrible attack. She shot herself in the head with his Luger.
You have a Luger, Master.
Yeah, but if I shot myself in the head, it would just sting a little bit. But yeah, so she did that. And do you know what he did the next day?
He arranged her funeral and he was horribly distraught.
No, he flew off to the front again because he didn't give a damn. So he wasn't a very nice man, this Fritz Haber. He's the one behind it. Great chemist, let's be fair. Okay, so that was in April. The Allies, though, of course, wanted to respond to that, as you can imagine, because everyone had heard in the newspapers and everything else how terrible it was. They wanted to respond. So we all got out our gas cylinders, filled them up with chlorine, plenty of that knocking around in Britain. And then we released all that gas at Loos in Belgium on the 25th of September 1915. This is all 1915, if I didn't say already. And I imagine, well, what do you think happened, girls?
It was a staggering success. We released the gas, and then we marched forward, kicking our footballs, and we wandered through to Berlin and ate a bratwurst.
The wind changed, and it blew the gas back over our own lines.
Oh, not so good then, Master.
No, not so good. That was the Allies' first attempt at releasing gas, and that kind of put them off using canisters, because it was never a great idea in the first place, and it relied on the prevailing wind staying in the right direction, and it didn't always do that. But unfortunately, the Germans, with their mendacity and their creative genius and their massive chemical industry that we didn't have, they later, not much later though, started producing vast amounts of phosgene.
Oh, that sounds bad. Phosgene. Is that like phosphorus or something like that? Something like burny thing?
No, actually, phosgene, and again, Master Andre could help us with this. That's Greek for the bringer, or gene, Genesis, comes from phos, light, I believe in Greek, comes from light. You make phosgene by irradiating the the precursor chemicals with ultraviolet light. Now, I forget what they are, but they're very simple, easy to obtain chemicals, and that's how you make it. So it comes from UV light. That's where phosgene comes from. December the 19th, so not much longer on, December 19th, 1915. Now, how would you know a phosgene attack was coming?
Smelt bad. Maybe you saw it moving sideways from the shrubbery.
Yeah, kind of. It smelt like musty hay or horses.
Oh, I quite like the smell of horses.
Yeah, well, I don't. But, yeah, whatever, Sparehead. Yeah, it smelled like musty hay. Now, this was different, though, all right? Because phosgene was colourless. You couldn't see it coming, really, unless it hadn't been very well made and there were pollutants in it, there were contaminants. Much like whenever I do experiments in the lab, there's always seems to be something that's crept in due to my dodgy technique.
Master, you are pretty rubbish in the lab.
Yeah, I know. Yeah, but so unless there were contaminants, the thing was colourless. It could even be odourless, to be honest. But very often there was this smell of like musty hay. Some said it smelled like rubber. But it wasn't a great gas in some ways because it didn't immediately immobilise and incapacitate the soldiers. What do you think it did?
Maybe it made them start dancing or something. Yeah, the tap dance or some kind of ballet.
No. What it had delayed effects. So after about 12 to 48 hours, their lungs would fill up with fluid. They would come down with pulmonary edema. Yeah, fluid in the lung. And the moment your alveoli fill up with fluid, you're kind of stuffed because well, you can't do gas exchange anymore. You are going to suffocate. Your oxygen saturation in your blood's going to go down.
Thankfully, we don't have as long as our blood, Master.
Yeah, so that's what phosgene would do. The reason why, it was a very powerful alkylating agent, which means it binds with anything it comes near, and had a particular affinity for certain proteins within the lung, the deep lung, the alveoli, the deepest part of the lung, the respiratory part of the lung, not the airways, but the respiratory part, the bit that does gas exchange, oxygen in, carbon dioxide out, all that kind of stuff. And it would bind with those proteins, and it would do terrible damage, and then the lung would fill up with fluid, and suddenly, even if your airways are clear, if your alveoli are full up of fluid, what's going to happen to you, Sparehead?
If your alveoli are full of fluid, Master, you're dead.
Yeah, so it's a really horrible gas. All right. So, that brings us on to mustard gas. Okay, have you heard of that, girls?
Very famous, Master. We've heard of that.
Now, why was it called mustard gas?
Because it smelled of mustard.
Yeah, it had kind of horseradishy, mustardy, kind of weird odour. But it's an interesting gas. And at this point, I know we've got some students that do watch the channel. So we're going to move you aside.
You shoved me!
Get aside. Okay, this is the structure of mustard gas. So you have a sulphur. Let me take the top off so I can point better. Just ignore Joe Calzaghe. He's a bit of a cokehead these days. So we've got sulphur in the middle there. And then we have 2 carbons, and then we've got the chlorine on the end. And it comes out both sides, all right? Now, what's going to happen with that? What do you know about chlorine? Chlorine, going down to the next picture, is a powerful, powerful electrophile. So what it does, it drags in the electrons. So chlorine drags in those electrons. That's why I've done a little delta. Again, shout out to Big Chris. That's a Greek letter. Delta minus, so it takes in the electrons. That's the carbon there. The carbon is stripped of the electrons. So basically the chlorine loves the electrons. It slurps them in. It sucks them in. But then what happens is the chlorine can happily jump away and find a proton just knocking around.
Why would there be protons knocking around, Master?
Good question. Well, everywhere there's water, right? Our atmosphere has a ton of water in it, you know. Whatever the humidity is, I don't know at the moment, but there's a load of water around, and if it's on the skin, if it's in the lung, if it's under the armpits, if it's in the genitals...
You was going to say a real word then, Master, weren't you?
Yeah, unfortunately, it did target those areas. The sweaty, damp areas is where it would target. And that chlorine would jump off, and it would find a watery, sweaty, damp patch. And what do you think chlorine plus hydrogen makes? Even you can work that out, Sparehead, can't you?
Hydrogen chlorine iode?
No, hydrochloric acid. Pretty nasty.
That sounds pretty nasty, Master.
All right. But what we're left with after that, after that little reaction, okay, we're left with the sulphonium ion, which is here. So what's happened is, right, that sulfur has been stripped of its electrons, therefore it's left with a positive charge. It can then go round, sorry, I said sulfur, didn't I? That carbon has been stripped of its electrons by the chlorine that's gone off, been left behind without its electrons, therefore its charge is positive. Well done. And the positive charge loops around, and then the sulfur has lots of spare electrons, and so it binds with that. And so we end up with this sulphonium ion, but the problem is, because we lost our electrons, we still got a positive charge here. And that positive charge tends to sit on the sulfur. And that is a target for DNA, which all the bases, adenine, thymine, cytosine, guanine, they all have loads of electrons knocking around. And those can literally zoom in, and they can bind with that. And what that will do then, suddenly you got a lump of DNA with this big, great sulphonium ion stuck on it. And what's that going to do, girls?
That is going to mess up cell replication.
Yeah, it's going to mess up cell replication. And so these things, not only will they cause immediate damage to the lung and to the skin and to particularly the sweaty areas they come in contact with, they will also cause long-term damage. It's very much like free radicals knocking around. They bind with stuff, they alkylate things, they stick on those chains of carbons and everything. And what they do, they're going to cause cancer in the long term.
Oh, Marcia, is it safe to even draw one?
I don't know, hopefully. But anyway, yeah, so that is that. That is why mustard gas is such a horrible gas. But let's bring you back into shot.
Thank you for bringing us into shot.
Oh. Show, baby. Cover yourself up. We saw crack. All right. Come on. There you go. Back into shot. All right, that's mustard gas. Who do you think invented that?
I'm getting those dastardly Germans.
It was. So interestingly, in the immediate term, mustard gas, like I said, it causes alkylation, it causes damage to whatever it touches. The word here to learn, guys, is vesicant.
Sorry? I learned it, Master. Vesicant.
What's a vesicant? Anyone know?
I can't say it, but I'm going to guess it causes blisters.
Yeah, it's a blister forming agent for the reasons I just outlined with the chemistry. It will cause blisters to the skin, blisters in the lung. It will cause blisters wherever it touches, especially damp areas, because remember it made that hydrochloric acid, which is a weak acid, but you don't want it in your lung or in your...
You were going to say a rude word again, weren't you, Master?
Yes, I was. Okay, so yeah, horrible stuff. That was introduced on July the 12th, 1917, again by the Germans. It caused 100 in the war entirely. It caused 120,000 casualties.
Master, you pretend you're clever, but I see you're looking at your notes.
I don't remember numbers like that. 120,000 casualties, but not deaths again. These things, but we don't know the long term, much like with the that which must not be named, double jab, and what we're seeing in the world at the moment. We don't know about long time casualties, got no idea about that. But in the short term, 120,000 casualties, but very, very few deaths, because it would blister you up and it would incapacitate you, then the infantry would overrun you.
Master, we're infants, could we overrun you?
No. All right, so what we haven't covered yet is the Allied response. So talked about using the gas canisters, didn't work very well, blew back over our own lines at loose. Come 1918, though, what were we doing?
Once again, Master, crabs showed their battle potential. We started loading up their shells and hurling them over the lines.
Good. We started filling shells with these poisonous gases, and we'd have a blend of them. Would it just be an attack just with poisonous gas?
Probably not just with the poisonous gas, Master. They would probably have blasty shells and shrapnel shells and all kinds of shells. Or, coconut crabs, Howdy moon crabs, hermit crabs, any kind of crab.
Exactly. So it'd be a blend. You'd use a blend of poison gas, of high explosive, of shrapnel, all those things you said. So well done, girls. Your knowledge is very good. So we started filling the shells with gases. And that was in June 1918, though. So we took our time, didn't we? We took our time.
We're Chinese, I think, Master, so, you can't say we. We're talking about ours.
All right, fair enough. The British took their time, and the Americans and the French. And the Italians, they were on the side too at the time. October, this is an interesting point. What happened in October on the 13th to the 14th that night at Ypres to Hitler? You've heard of him, right?
We love his speeches. He's such a wonderful speaker, Master.
He was. And what happened to him then? He suffered a gas attack.
Oh, I hope he survived and he was fine.
Yeah, sadly he did. He survived it. As we said, most people survived a gas attack, but they had permanent problems. Hitler, in October there at the Ypres, he survived a gas attack by the Allies, but he was blinded initially by the gas, totally blinded. And he didn't regain his sight, they say, until a month or so later, after the war was over.
Oh, the war was over? I thought we're still fighting, Master.
No, just because I shoot you on the range doesn't mean we're still fighting. So the war is over. And what he said, do you know what he said after that? He said, my reason for being able to speak the way I do, and he had a wonderful sing-song voice, did Hitler. It's a pity that most guys don't understand German, because the way that man spoke, it was mesmeric. It was mellifluous, if that's a word. I believe it means flows like honey, mellifluous. He had a wonderful way of speaking. And he pinned that all down to the gas attack by the Allies.
So basically, we created Master Hitler. Yeah, it's kind of funny, Master.
Yeah, well, that's what he claimed anyway. So the war ended when he was in hospital. I think he was at some kind of retreat in Austria recovering. Anyway, so we've gone through all of that, right? That's pretty much how it ended. So gas caused mass casualties, 1.3 million casualties in the war, they say, from the gas, but less than 1% of the deaths, because these things were, by and large, irritant, vesicant, really unpleasant, maybe caused loads of deaths later by cancer, we don't know, but at the time, they were not immediate killers. Has any good come from any of this stuff?
Yes, we now have organophosphates, so we can kill people better!
You're worrying me, Aquanoir. That's not what I was going to say. No, one bit of good that has come from it is we now have the nitrogen mustard. So, let's get back to that. Sorry, girls. Instead of having the sulfur in the middle, we stick... Get out of the way.
Hey!
Okay, sorry. We now stick a nitrogen there. All right. And that is what we use today to treat cancer. It's an alkylating agent. It does the same thing. Because what happens in a cancer cell...
Master, you're annoying me. But what happens in a cancer cell? We have unregulated replication.
We have unregulated replication. And what, if you're making lots of new cells, what do you need lots of new stuff of?
DNA.
Well, DNA, but yeah. So when you replicate cells, you make loads of new DNA. So there's replication taking place. And if you can target... Show, baby. Cover yourself up, girl. If you're making lots of new cells, you're having to do mitosis, make lots of new DNA. And these agents, as we said, that one there, mustard gas, will target the DNA. That's one of the things that they do. And so they've been used very successfully as anti-cancer agents. Obviously now we do have more targeted ones that use antigens and so on to target the chemical to the place. But they've saved many lives through the years by their targeting of replicating cells. Because in the body, we don't have too many cells that are actually in mitosis. Most are in interphase where they're not doing any replication. So those drugs... they've had a value.
Master, you're waffling on again.
All right. Well, I'll cut it out now, but okay. So also, guys, anyone that does listen to this, check out Benjo's True Crime as well. Yeah. So, big up the nitrogen musters. Those have saved lives. As for the rest of it, as for Fritz Harbour, yeah,
We don't like him.
we don't.